This question is from GATE 2019, Mechanical Engineering paper, set 2, question number 5. A rigid triangular body PQR with sides of equal length of 1 unit moves on a flat plane. At instant shown, edge QR is parallel to the x-axis and the body moves such that velocities of points P and R are Vp and Vr in the x and y directions respectively. The magnitude of angular velocity of the body is. So among these four options, we need to find what will be the angular velocity of the body at this instant. Now in order to find the angular velocity, which will be your combined effect of Vp and Vr, we will have to first understand instantaneous center, because angular velocity omega of this triangular body will be nothing but magnitude of velocity at point P divided by the distance of P from instantaneous center. So if we say instantaneous center is I, it will be Vp upon Pi, or so angular velocity omega is also equal to Vr, magnitude of velocity of point R, divided by the distance between R and I, that is Ri. So in order to find out these distances, we'll have to first locate the instantaneous center, and we will start by understanding what is instantaneous center. It is a point located either within or outside the body which is rotating, and at this point the velocity will be instantaneously zero, means it will be zero for a particular instant at that particular point. At another instant, the point may shift and again the velocity will be zero at that next point. So instantaneous center is particularly only valid for an instant. Now for locating the I center, let's consider a body in which there are any two arbitrary points, point A and point B. Let's say the velocities at point A and point B are directed somewhat like this. To find out the instantaneous center of this body at this instant, when the body is of course rotating, because the velocities are in these arbitrary directions, the body is going to rotate. Being the effect of direction of velocities at different point, it is going to rotate, and it will rotate about this instantaneous center at this instant. So if we draw perpendicular lines to A and B, we can locate the instantaneous center. In this case, we have drawn the perpendiculars to the velocity vectors. The point where they intersect is nothing but the I center or the instantaneous center. In this particular problem, we will find out the location of the instantaneous center. So this is the triangular body that is given, and point P, point R are having their velocities directed as shown. Now we have drawn these perpendiculars to the velocity vectors, and we see that these perpendiculars are meeting at this point, which we call I, instantaneous center I. Now in this triangle, all sides are equal with unit length. It's an equilateral triangle. Its vertex angle will be 60 degrees. In order to find out the distance Pi, it's either Pi or Ri that we need to calculate in order to find angular velocity omega. In triangle PIR, it's a right angle triangle. Of course, perpendiculars are meeting at this point. There is a right angle forming. So in this right angle triangle, if we write Pi, it will be hypotenuse PR into sine 60 degree. Now PR value is 1 and sine 60 degree is root 3 by 2. So we have value of Pi to be root 3 by 2. Next we need to find out distance Ri. For that we will use Ri is equal to PR cos 60 degree, which is equal to PR is 1 into cos 60 is 1 by 2. So we have Ri to be 1 by 2. Now when we have Ri and Pi, we can use the formula for omega and find out the angular velocity that is being asked. So we can write it as Vp upon Pi, Vp upon root 3 by 2, which is nothing but 2 Vp by root 3. But we notice that 2 Vp by root 3 is nowhere in the options. From here you can get a clue that you will have to find out the angular velocity in terms of Vr. Going back and finding the angular velocity in terms of Vr, which is equal to Vr by Ri, Vr upon 1 by 2, which is equal to 2 times Vr. So 2 times Vr is there in the option. It is the option 1. So the correct answer is angular velocity of the triangular body that is given here is 2Vr. To learn more about instantaneous center and rotational motion of bodies, you can refer to lecture 26, relative motion 3 and instantaneous center, the course Engineering Mechanics by Professor K. Ramesh, IIT Madras. I hope you understood the solution. Thank you.